Good afternoon, evening, or morning, calculus people. This is the max min unit. We're on day 3 today, or day 4, I guess, because we had a work period or two, a couple days of work period there. So we'll call it lesson 4, I guess. And what we're going to look at today is we looked at max min problems that dealt with volumes, making boxes, fencing, perimeters, and area of printed page. Okay, so and that's just a sample of a few, and then we had a bunch of different practice ones there. Even looked at a cost one. So now we're going to look at a distance problem, max min problem that uses Pythagorean theorem. So use the triangle formation. Okay, so that's what we're going to look at today. Pardon me. I'm only going to do maybe 2 examples here, and I'm not going to give any practice for. Well, actually, I will give some practice for this. But what I'm gonna do is I'm gonna do the examples and give a whole period for practice. Do the exam because this is the most important unit. So we'll slow down a little bit now here that we're getting into May here, or close to it, depending on where we are. Okay, so this is day number 3 or 4. If we 4, we'll say because we had a work period, and we're going to be looking at basically distance problems. And I've got one here that I've saved up from that I'll just paste in here. Okay. Oh, this one here is a little bit bright. Per meter, that is. Okay, so it says distance problem that uses Pythagorean theorem. SaskTel is going to string a cable underground between towns A and B. Town A is on the north side of a river and town B is on the south side of the river. Town B is 2,000 meters west of town A and the river is 460 meters wide. The cost to install the cable under the ground is $50 per meter. That's per meter. But if I put the slash in there, it goes like that, and that looks stupid. Per meter. Let's see if I can. And underwater is $120 per meter. Yeah, it doesn't want to let. So these are per meters in here. Find the distance where the underground cable is changed to underwater cable at min cost. Okay, so I'm letting you write that down. Change that a little bit smaller. See if I can put per meters in here. There we go. Per meter. That looks better. And we'll put per meter in here. Up smaller. Oop. SaskTel is going to string the cable underground between towns A and B. Town A is on the north side of the river. Town B is on the south side of the river. Town B is 2,000 meters west of Town A. The river is 460 meters wide. The cost to install the cable underground is $50 per meter, and underwater is $120 per meter. Find the distance where the underground cable is changed to underwater cable at min cost. So let's draw the picture. All right, so let's draw the picture. So we're going to do a Pythagorean picture. We're going to string this along here, and this is going to end up using Pythagorean theorem in the end. Okay, I'm just going to Move this up a little bit here. Okay, so let's draw the banks of our river. Let's use the straight line tool here. Here's our river. Okay. Now, according to this, it says marker. Okay, town A is on the north side of the river. Okay, and then town B is on the south side of the river, 2,000 meters to the west of it. So town B is down here. Okay, and if we look at this, is this being perpendicular here? And this is town B here. This is 2,000 meters. Okay, and it's asked the cost, blah, blah, blah. Okay. Find the distance where the underground cable is changed to underwater. The distance where the underground cable is changed to underwater cable. Okay, actually, it should be where the underwater cable is changed to underground cable. So, say the change happens here, some distance away. Let's call it X. Okay, so let's say that C or X is the distance. X equals where they change cable from underwater to underground. Sorry, guys, it's going to go underwater first and then underground. Or we could have gone like this as well. We could have went and then across like that. Okay, which is probably what I should have done based on the way I've got it written here. But I went underwater first and then across. So the path that I have here is this path right here. So this is underwater. Okay, and then this path here, we'll put in green, is underground. So that's the setup. Okay, so now we have to find a equation for the formula. Okay, now the other thing that we know here, and I'll go back to my marker here, is that this river is 460 meters wide. So we can find out the hypothesis of this underwater. So the underwater cable the distance of the underwater cable. Okay, that's going to be the hypotenuse. So it's going to be x squared plus 460 meters squared equals the distance underwater. So we can call that, we'll call it C, A squared plus B squared equals, we'll call it R squared. Okay, so the distance of the underwater cable we'll call R. Okay, so that's what we're going to do. So we have to figure out an equation for R. What does R equal? So R equals the square root of x squared plus 460. Okay? Squared. Squared. Okay, so if we're going to work that out, R equals the square root of what's 460 squared? That's 211,600. So I'm going to put that in front. Okay, so that's the distance. So R equals, if we're going to write it in exponential form, we're going to say 211,600 to the power of 1/2. And we're going to end up having to take derivatives and stuff, so it's a lot easier to have the power of 1/2. So that's a distance under the water. The distance under the ground is simply 2,000 minus x. That's way easier to do. So let's call the distance under the ground d. Distance underground. Okay, so that's going to equal 2,000 minus x, because it's just going to go from C to B. It's going to be this 2,000 minus whatever that x is. So that's easy. We don't have to do any square rooting or anything. Okay, so now we have to do the cost. Cost. Well, let's do it in black here so that we don't. Cost. So the cost equation is the price times the distance. Price times the distance. Okay, so let's do the underwater first. The underwater is $120 per meter. So that's equal 120 times 211,600. Oh, I forgot to put the X. Man, oh man, look at that. No X in there, Rob. What are you doing? I forgot this X squared right there. That would be silly of me. So let's fix that first before I go on to that. All right, so I should have had 211,600 minus x squared to the power of 1/2. There, that's better. Okay, so then we're doing our cost. Okay, that's $120 times this. Okay, don't bother trying to bring that into both of these because it doesn't work that way. That's one term there under the root sign. Okay, plus $50 times the cost of underground cable, which is 2,000 minus x. So then here's our cost equation now. So we should simplify our cost equation a little bit. We can multiply this out. Well, this one here we can't. We're going to have to use the chain rule here. But this one we can't. We can multiply this one out and simplify it a little bit. Okay? So this one we can't do much with. Well, we could multiply this out if it was by itself. But remember, it's the root sign here. So don't get messed up with the root sign. So don't do that. Okay, that's a root sign, that half. Okay, but this has nothing to worry about. There's no power here, so we're okay. So we can go ahead and go 10,000 minus 50x. All right, so now when we get this equation, we can take this equation and we want to minimize it. So the only way to minimize this equation is to basically take the derivative. of this equation. Okay? The derivative of this equation will give us a minimum or a maximum point, right? Because that's the critical point. So now we have to take the derivative here. Okay, so let's do the derivative. C prime, we'll call it. Okay, so the derivative of this is a chain rule. So 1/2 times 120 is 60 times this whole thing in there. Times minus 1 from that, which would be negative 1/2 power there. Okay, and then times the derivative of what's inside. The derivative, this is 0. Derivative of this is negative 2x. Okay? Or sorry, positive 2x. Why do I have a minus? What am I doing? Boy, you guys, that's a plus sign, right? Good thing I'm not on it today. I'm sorry, guys. This should be a plus. Make a big difference if we, right? Because we're doing the hypotenuse here. We're adding, these are added here. So that should be the plus. That's minus there, but this is plus here. Okay, so that makes more sense there. So then if derivative of that will not be a negative 2, it'll be up 2x. Okay, and then the derivative of this is 0, and the derivative of this is negative 50. Oh boy, sorry guys. It's messing up on my plus signs there. Okay, but I think we got her now. Okay, so now we have this derivative and we have to set it to 0. Okay, so we can take this 2x out here and write this as 120x times this whole thing. Power of negative 1/2 minus 50. Okay, so now we have to solve this. The easiest way to solve this is to write this as a fraction and cross multiply. So remember that this negative 1/2 is the root on the bottom of a fraction. So if we took this and put it all under the 120, let's move the 50 over first to make it plus 50. Okay, so that goes over there. And then this can go underneath. So it'll be 120x all over the square root of this whole number. Okay, so now it's on the bottom, so now it's just the square root. Okay? All right, now we can, that's the derivative, set to 0. Now we have to solve for it. Solve for x. And you're like, oh no, what do I do to solve for x? Well, this is where we cross multiply our equation. Okay, so what we're going to do here now is we're going to multiply this and consider this like 50 over 1. And then we're going to cross multiply it like this. Okay, so that's how we're going to solve. So we're going to have 50 times 211,600 plus x squared. Gosh, I'm going to make an error here if I'm not careful. To the power of 1/2. Okay, equals 120x. Okay, so now we have to do pre-cal 30 stuff. We're going to have to square both sides eventually to get rid of the root sign here. This is a root sign. So now this 50, we can divide both sides by 50 to get rid of this 50 in front of it. So now forget the x squared. Okay, 120 divided by 50 is 2.4. Okay, so now we can square both sides to eliminate the root sign here. Square of this side and square of this side. Okay, so the square of this side is going to keep the same number because the root sign just disappears. Okay, 2.4x squared. Okay, what's 2.4 squared? 5.76 x squared. Okay, now it's simply a case of solving for x squared. So you can bring the 1x squared, subtract 1x squared for both sides. Divide both sides by 4.76. Say, take your 200,011, 600. Divide by 4.76, and you get 44,453.78 or 0.8 equals x squared. And then we square root both sides. Okay, now we get a positive negative result, but the negative will not make sense because you can't have a negative distance of cable, right? So I get 210.8, so I get 211 plus or minus. Therefore, x equals 211 meters Okay, so now the question asked us, now the question might ask us how many meters of underground cable do we have and how many meters of the other cable or what the total cost is or whatever it says. Find the distance. Okay, so you have to be 211 meters west of the point on the river before you start crossing the river or before you go to underground cable. Okay, so you are west of town A when you hit the bank of the river. Okay, and I know I didn't ask this question, but they might ask it, so you could find out what each distance is. So therefore, underground which was D, was 2,000 minus X, which would equal 2,000 minus 211, which should be equal to 17, 89 meters when underground, and underwater was, okay, what was that one? That one was, underwater was square root of x squared, what is it here? There it is, x squared plus 460 squared equals r squared. So r was this number here, 211 minus 600 x squared. Okay, so r was 211 600 plus, make sure I don't put a minus in there, yeah, plus it should equal okay, so let's work that one out. 211 squared plus that, square root that. So I get 506 meters that went underwater. So then if you wanted the cost now, if I ask for the cost, this would be 50 times 1789 plus 120 times 506. Okay. Okay. So $150,170. Okay, so there's a couple extra questions that could have been asked that I didn't ask. So that's a typical distance question. Let's take a look at our time. Okay, that gives us about 25 minutes. Okay, so I will give you a work period. There's a whole bunch of different kinds of distance problems, so let's just take a look at them. Okay, that's only one example, but they all are fairly similar to that. Okay, so let's take a look at those. Let me first bring it up on my screen here for you, and then I'm going to give you this day plus the next day, okay, the rest of this period plus the next day to work on some distance problems. Okay, so, and maybe next day what I'll do is maybe I'll just do one more example or something and let you work again. Or maybe I'll just leave it blank. So let's get to the distance problem here. Okay, so that's integration. No, we don't want that. That's next unit. Okay, so distance problem, assignment. Okay, it's just going to come up here. There it comes. Okay, so there are solutions for this as well. I'll scan this as soon as it opens up. Okay, so here's some examples of the distance problem. Wow, this one actually should, I can probably move. Okay, so, okay, there's an example. Here's one with one that I did. Okay, very similar. Okay, here's one with a hunter and velocity. Okay, so time is d over t. There's a hint in there. Here's another one like I did. Another one like I did. Another one like I did. And another one like I did. So there's 6 problems there. So next day you can work through these 6, which I'll put up for you, and you can start today if you want, and just get some practice. So we're going to kind of slow down a little bit and just do. Here's an example. How do you do it? We got to do spheres, cones, cylinders, and troughs and rectangle prisms are the next ones that we do. So we're going to do like one every 2 days kind of idea. Okay, so there's your practice. So work on those practice for next day. I'll put it up under next day, but you can start today if you have time. I opened it twice. We don't need that. Okay, so I'm going to stop the video there, and you can work on that today and tomorrow.